Okay, so in today's lesson, we are going to start talking about chemical reactions, and we're going to start here first with what's called the law of conservation of mass. But before we do that, we want to get a little bit of a background here on exactly how chemical reactions are set up. Okay, so this would be a generalized chemical reaction. Okay, so this is how we typically write it. On the left-hand side here, we have what are called the reactants. These are all of the elements and compounds that we put into a chemical reaction. After the reactants, we have this arrow, and the arrow is pointing from the reactants to the other side. And what that indicates is that we have a chemical change going on. So the elements and compounds are being pulled apart and rearranged to form new substances, which would be on the right-hand side of the arrow, which would be products. So as an example reaction here, we have CO2 plus H2O, and we would pronounce the arrow as a yields, so CO2 plus H2O yields H2CO3. So in this reaction, my carbon dioxide, my CO2, and my H2O would be my reactants, and the H2CO3 would be our products. It's really important that we understand what goes where. Okay, reactants are what we put into, and what is produced is the products. Now, all reactions that we have, chemical reactions, have to obey a law of science called the law of conservation of mass. And basically, what the law of conservation of mass is going to state is that the amount and type of atoms on the reactant side must equal the amount and type of that same atom on the product side. In other words, the mass of the reactants has to be equal to the mass of the products. Okay, so basically what this is saying is that if we have a certain amount on the reactant side, we can't magically create something new or more of what we started with on the product side. By the same token, we also can't get rid of anything. Another way of thinking of the law of conservation of mass is that matter cannot be created nor destroyed. So it's very similar to that law of conservation of energy that we talked about a few units ago in our energy unit. So what I want to do is, if you need to pause the video to get the conservation of mass worksheet, I actually want to spend a little bit of time going through that. So if you need to get that worksheet, then let's go ahead and pause the video so that you can do that. So now at this point, what we want to do is take a look at these following problems and show how they follow the law of conservation of mass. Okay, so if we look at the first problem, we have a reaction up here. And if you look, the KClO3, this is our reactants, and this is our products. Okay? So if we read the words, it says 500 grams of KClO3 decomposes and produces 303 grams of KCl. How many grams of O2 are produced? Well, remember, the mass of the reactants has to equal the mass of the products. So what we want to do is we actually want to think of that arrow as an equal sign. Okay? So this gets kind of changed into an equal sign in terms of the mass. So let's go back to the problem. In the problem, we say we have 500 grams of the KClO3. So we will set this up as a math problem. We have 500 grams, and that is equal to, and then we have 300 grams of KCl. Okay, so we have 300 grams, and plus sign, how many grams of O2 are produced. So this is what we are looking for, is X. Okay, so now this is a really easy algebra equation to solve. We subtract 300 from both sides, and so we get 200 grams equals X. So from this information, we would produce 200 grams of O2. And actually, for those of you worrying about sig figs, our sig figs are fine. Remember, with addition and subtraction, we look at the number of decimal places. So we don't have to count anything other than decimal places. Okay, let's try number 2. How many grams of H2 are needed to react with 100 grams of N2 to produce 121 grams of NH3? Okay, so let's come back up here and look at our equation. Our first reactant is N2, and we know we have 100 grams of that. Plus, H2 is what we're looking for. Then comes the arrow, which is our equal sign, and we have 121 grams of NH3. So we subtract 100 from both sides, and X is equal to 21 grams. Okay, so we have 21 grams of H2 that would be produced. All right, let me just move this up a little bit here. So hopefully I can all three of them. Oh, yes, I can. There we go. All right, so number 3, how many grams of oxygen are needed to react with 350 grams of iron to produce 500 grams of Fe2O3? So iron, okay, that's Fe, so we have 350 grams of iron plus oxygen, that's here, that's what we're looking for, is equal to 500. Subtract 350 from both sides. So my X is going to be 150 grams. Okay, so I would need 150 grams of oxygen. Number 4, 16 grams of CH4 react with 64 grams of O2, producing 44 grams of CO2. How many grams of water are produced? So I have 16 plus 64, and that equals 44 plus X. Okay, 16 grams of CH4, 64 grams of O2, 44 grams of CO2, trying to figure out what this is. Okay, let me add this on this side, so this is 80 equals 44 plus X. Subtract 44. So this would be 36 grams of water. Okay, so the last one. How much carbon dioxide is produced from the decomposition of 200 grams of calcium carbonate, CaCO3, if 112 grams of CaO are produced? So I've got this amount here, so I have 200 grams of CaCO3 equals 112 plus X. So I subtract 112, and that gives me 88 plus X. So I would actually get 88 grams of CO2. And it is just that simple. Okay, now in the next video we're actually going to continue our discussion of reactions by talking about energy and reactions.